Contrastive learning is the cutting edge approach that is revolutionizing the field of machine learning methods. So today in this video, we will understand the contrastive learning based techniques. So let's understand what is contrastive learning first. Now this contrastive learning is a way to train machine learning models by comparing similar and dissimilar examples. So imagine you are teaching a friend how to recognize different types of fruits. You show them a basket with several apples and few oranges and ask them to identify each fruit. So this is similar to contrastive learning, where the model learns to distinguish between similar examples, apples and oranges, and dissimilar examples, means other types of fruits. So to train a contrastive model, you first feed it with multiple examples of the same type, such as several images of apple, and ask the model to identify them as similar. Then you give it example of different types of fruits, say as oranges, and ask the model to identify them as dissimilar. So by repeatedly exploring or exposing the model to these type of examples, it learns to recognize patterns and features that distinguish one type of fruit from another. And in the context of natural language processing, contrastive learning can be used to improve language models by training them to distinguish between similar and dissimilar sentences. For example, a contrastive learning model could be trained to identify sentences that are semantically similar to a given sentence, such as synonyms or paraphrases, and distinguish them from the sentences with completely different meanings. Now next comes contrastive language image pre-training or CLIP. Now this CLIP is a method used to train models that can understand the relation between the text and images. So imagine you are teaching a child how to recognize objects in pictures and describe them using words. So you show the child a picture of dog and ask what animal is this, and then show a picture of cat and ask what animal is this. So in the same way, CLIP trains a model to compare images and text by using large data set of image text pairs. Now here the model learns to identify similarities and differences between them, which enables them to understand the relation between visual content and the words used to describe it. And to put it simply, CLIP is a way to train models that can understand the connection between the images and text, making them better at tasks such as image captioning, image search, and visual question answering. And to understand it better, let's take a real life example. So imagine you have a large collection of images and their corresponding captions or a text descriptions. And you would use CLIP to train a model by showing it an image and its caption together, and then asking it to describe other images based on their captions. Here, the model would learn to associate specific visual features with the words used to describe those features. For instance, if the model sees the image of dog, it would learn to associate the word dog with that image, right? So next, understand CLAP or contrastive language audio pre-training. Now this CLAP is a method used to train models that can understand the relation between text and audio. So think of it as teaching a child to recognize words in spoken language and relate them to their written form. So you would play a recording of that word apple and show the child the text apple. Then you would play the recording of banana and show the text banana. So this way the child learns to connect the spoken words to its written form. Now here the CLAP trains a model in a similar way using a large data set of text audio pairs to learn the relation between the spoken words and their written forms. So the model learns to identify similarities and differences between audio and text, enabling it to understand the connection between spoken language and written text. So let's understand it better taking a real life example. So imagine you have a large collection of text and audio recordings of the same text. So you would use CLAP to train the model by playing an audio recording of a sentence and showing its written form simultaneously. So the model would learn to associate specific spoken sounds with their written text. For example, if the model hears the phrase, "I love apples," it would learn to recognize the written text, "I love apples," when it sees it. So this allows the model to understand the connection between spoken and written language, making it better at tasks such as speech to text conversion, audio-based search, and speech recognition. Now next comes audio visual text clip or audio clip. Now this audio clip is a method used to train models that can understand the relation between audio, images and text. So it is like teaching a child to recognize objects in picture, relate them to their spoken description and connect them with the written words used to describe them. So you would show the child a picture of dog, play a recording of someone saying dog, and then ask the child to describe the picture using the word dog. So this audio visual clip trains a model by using a large data set of image, audio, text triplets. So here the model learns to identify similarities and differences between these elements, enabling it to understand the connection between visual content, spoken language and written text. So let's make it simple using a simple real life example. So imagine you have a large collection of images, their corresponding audio description, that is recordings of people describing the images, and text captions, that is the written description. So you would use this AVT clip to train the model by showing an image, playing its corresponding audio description and displaying its written caption simultaneously. So the model would learn to associate specific visual features with the spoken and written description of those features. For example, if the model sees the image of dog, hears a recording of someone saying dog and reads the text dog, it would learn to understand the connection between the visual content, spoken language and written text. And this allows the model to excel at tasks such as image captioning, audio-based search and multi-modal question answering. And in the end, let's understand this info NCE loss or the contrastive loss function. Now this info NCE is a method used in a type of machine learning called contrastive learning, and it's a way to train models by comparing relative examples and unrelated examples and adjusting their representations accordingly. So imagine you are training a model to recognize different breeds of dog and you have a collection of images of dog. Now this info NCE helps you learn from this collection by comparing each image to other images of the same breed and different breeds. And the goal is to create a feature space where images of the same breed are grouped closely together while images of different breeds are spread apart. Now the contrastive loss function is a mathematical tool used to train the model with the info NC method. So in this example, you would have an anchor image ZA, a positive image ZP of the same breed and multiple negative images, that is ZN. So the contrastive loss function calculates the similarity between anchor and positive images and anchor and negative images. And the goal is to maximize the similarity between the anchor and positive images by bringing them closer together while minimizing the similarity between anchor and negative images by pushing them apart. Now this temperature hyperparameter, the tau, it controls the strength of the similarity maximization, and lowering this temperature places a greater penalty on the harder negatives, making the model more selective and discriminative. So in simple terms, info NCE is like a coach who encourages you to group similar things together, example images of same dog breed, and separates different things, example images of different dog breeds. And the contrastive loss function calculates how well you are doing, and the temperature controls how strict the coach is. And by following this training method, the model learns to recognize the similarities and differences between various elements. Thank you.